Welcome to this tutorial video on edge-triggered D-type flip-flop. Sometimes when we're using logic circuits to evaluate Boolean expressions, we need to be able to store a result for use at a later stage. So, in other words, we need some kind of memory. And the edge-triggered D-type flip-flop is a type of logic circuit that we can use to store one bit. A positive edge-triggered D-type flip-flop comprises of several NAND gates, but at A level you don't need to know how these gates are put together inside this D-type flip-flop that I've got here. You just need to know how in principle it works. So we've got two inputs here. We've got D, a data input, and a clock input. And we've got two outputs here, Q and inverted Q. We don't need to worry about inverted Q at A level, you just need to know that there's an output Q. So the data input is just that, it's the data that is entering our D-type flip-flop. And the clock signal oscillates between 1 and 0 at regular intervals. So this is our clock signal here on a graph, and that's oscillating between 1 and 0 in the same interval there. So let's have a look at these graphs to see how the output of Q will change depending on D and the clock. And we'll see how we can use the D-type flip-flop to store one bit for a clock cycle. So this here, where I've labelled the oscillating clock cycle with an arrow there, a red arrow, that's the rising edge of a clock cycle. And we've got a falling edge as well here. And when the clock is not at a rising edge, the value of Q is always held and doesn't change. But when the clock is at a rising edge, the value of Q changes to whatever our data input is. Let's have a look at the value, what the value of Q would be then in this case where this is our data input going between 1 and 0, and this is our oscillating clock here. So the data input is not going between 1 and 0 at the same time interval, the clock is. So first of all then, the clock is on a rising edge here, and the data input is going from 0 to 1. So our value for Q goes from 0 to 1. So you can see here the next time the value that our clock is at a rising edge, where we've got an arrow red here, this is a rising edge on our clock. Our data is at the 0 state here. So that means that our value for Q moves to the 0 state. Next time then our value for the clock is at a rising edge, the data is still at a 0 state. So our value for Q is still going to be 0. The next time it's at the rising edge, it's still 0. So we continue with our Q at 0. But this time when it's at a rising edge, it goes to 1. So our value for Q moves to 1. But when we get to a rising edge here, it's at 0, so it goes to 0. So you can see here how our D-type flip-flop can be used to store the value of one bit. The important thing to note here is the value of Q only changes to match the value of our data input in response to a rising clock cycle. So for example, when our value for D changes here, our value for Q doesn't change because the clock cycle is not on a rising edge. Okay, so that's a introduction to a edge-triggered D-type flip-flop. Hope you found this video useful, and thanks for watching.